All right, let's take a look at the third type of way we solve systems of equations. We did graphing, we did substitution last video. Now today we're on to elimination. So let's take a look, elimination down here. These are the steps. Pause your video and write these down. I'm going to go through one by one. Basically, we're going to line up and have the same amount of x's or same amount of y's, so we can eliminate one of the variables. All right. Again, our goal is to get one equation with one variable so we can solve that. All right, let's take a look at this example here using elimination. I want you to think, because we're not going to tell you which way to use, but let's take a look. If we wanted to solve this by graphing, it's not in y equals mx plus b form, right? It's not in slope-intercept form. So we'd have to put it in that form. If we wanted to do substitution, remember, we want y equals or x equals, but I don't have a solo variable here, right? All my coefficients are different numbers. So I don't want to do substitution. I could, but I would have to start dividing by 2 or 3s or 5s to create 1x or 1y. So let's take a look at elimination. All right. Our goal with elimination, again, is to create the same number of x's or the same number of y's. All right. I don't have the same number of x's. I have 2 here and 5 here. And then for y's, I have 2 here and 3 here. So I need to make sure I need to do something to these equations to create the same number. Now, we're going to do that by multiplying these equations. Okay. If I multiply the top one, to get the same number of x's, I'd have to multiply by 2.5. To get the same number of y's, I'd need to multiply by 1.5. So actually, I'm going to multiply both of these equations here to create the same number of x's or y's. Now, you can do x's or y's. I think they're equally as difficult in this equation. What I'm going to do is create the same number of x's. I'm going to focus on x's. I'm going to multiply this top equation by 5, because then I'd have 10x. And I'm going to multiply this bottom equation by 2, because then I'd have 10x. Now, the last thing here is I want opposite signs. So I'm going to multiply by -2 on the bottom one. Okay. Let's take a look at what this looks like. If I multiply the top equation by 5, I have 10x minus 10y equals, now here's the thing, everyone always forgets to distribute this 5 to that 6 as well. Everyone always forgets that. So don't make sure if you're multiplying an equation, you need to multiply every part of that equation, otherwise it doesn't stay equivalent. All right, on the bottom here, let's multiply by -2. I would have -10x plus 6y equals -18. Again, don't forget that one there. All right, we got to distribute to each part of that. Okay, now you can see I have the same number of x's, right? Opposite signs. At this point, I'm just going to add these two equations together. 10x plus -10x, 0x. -10y plus 6y, -4y. 30 plus -18 is 12. So we have basically 0x, get that out of there. We have -4y equals 12. I'm going to divide by -4 on both sides, and I get y equals -3. Y equals -3. Okay, again, the goal is to create one equation, one variable. Once we do that, this kind of opens everything up for us, right? If we know y is -3, we can plug back into one of those original equations. So I'm going to take first or second, doesn't matter. I'm going to take this first equation, 2x minus 2y equals 6, but I'm going to now substitute. If we know y equals -3, instead of y here, I'm going to substitute -3. Okay, all right, just substituting in there for y. Let's finish this up. 2x, I had -2 times -3 is plus 6 equals 6. Solve for x, subtract 6 on both sides, 2x equals 0, divide by 2, x equals 0. So we get x equals 0, y equals -3. Let's put that as an ordered pair. We have 0, -3 is my solution to this system of equations. Again, let's be good mathematicians here. Make sure you're checking your work. If you plug this back in, it should make the top and the bottom equation both true. So make sure you're checking your work as you go along. All right, let's take a look at one more together. We're going to solve this one by elimination again, because there's a certain case that shows up, and I want to show you what that looks like. Okay, I don't have the same number of x's. I don't have the same number of y's. I'm going to line up the x's by multiplying this top equation by 3, except then I'd have 6x, and 6x, I'm going to do -3. All right, if I do that, -6x plus 3y equals -12. That second equation, I have 6x minus 3y equals 12. Add these together. All right, -6x plus 6x, 0x. Right, we're using elimination. 3y minus 3y, eliminated, plus 0y. -12 plus 12, eliminated, equals 0. If we get 0 equals 0, right, this is true. That makes sense. This is going to be one of those cases where we have an infinite number of solutions. If you take a look at these lines, I'm not going to put them in slope-intercept form, but basically these lines are right on top of each other. Okay, those lines are right on top of each other. So this point is a solution of the equation. This point, every point on those two lines is a solution to the system of equations. So when you get a case like this where you run into something that is true, we have infinite number of solutions. So those are the three cases you should have seen by now. We could have one solution, we could have no solution, or we can have infinite number of solutions. All right, good job. I'm going to let you guys try one yourselves now.